In this video, we're going to be talking about factoring and what that means and how to do it. So first, before we do anything else, let's talk about what is factoring. For purposes of this class, we're going to use this definition, separating a polynomial back into a product. So the last unit, we did a lot of multiplying monomials to polynomials and binomials to other binomials and polynomials to polynomials, where we multiply them to get it into its simplest form, into one polynomial. Factoring does the opposite of that. We are now taking that simplest form and going back to that factored form. And I'm going to explain here in a second how we do that. As we start looking at these polynomials, if we get to something that can't be factored, those are going to be prime. So you can relate that to like prime numbers because the only factors of prime numbers are one in itself. Same can be said with polynomials. The only thing you can really take out or factor out is a 1. So let's look at the steps on how to factor. First, you need to know that there are many different ways to factor polynomials. In this video, we're really just going to talk about one of them, and that's factoring with the greatest common factor. In order to do that, we're going to identify what the greatest common factor is. So that means we're going to look at the coefficients and see, is there a number I could divide out of both, but not just a random number. I got to look for the highest number possible I can divide out of both. So if I go back to this example up here, the highest number I can divide out of both of these coefficients is 4. I can't divide 8 out because I'm going to get a fraction or a decimal, and I want them to be whole numbers. But if I were to divide 4 out of both of these numbers, that would be my GCF, or part of it. That's why the 4 is on the outside. Then, I have to look at the variables. A variable must be present in all terms to be a GCF. If the variable is present in all terms, we're going to take the one with the smallest exponent. So looking back at this example, I see that this has 2 terms. One has an a squared, and one has just an a, or an a to the first. Because I cannot take 2 a's out of both of these terms, because this one only has 1, I can only divide 1a from both of these terms. So that is my part of my greatest common factor, which is why this a is outside. So altogether, my GCF is 4a. So I take that GCF and I put it on the outside of the parentheses, and then I divide each term by the GCF and leave the remaining factors in the parentheses. So if I go back to this original and I divide both of these terms by 4a, the numbers or the coefficients we divide like normal. So 4 divided by 4 is 1. The variables, you have to remember your exponent rules. If I am multiplying, in this case dividing, if I'm dividing by like bases, I am subtracting the exponents. Which would leave me with 1a left, which is why there is 1a inside. The 4 divided by 4 to get 1, there's an invisible 1 in front of a, we just don't need it. For the second term, when I divide it by 4a, 8 divided by 4 is 2. A divided by a is a to the first minus 1, which would be a to the 0. almost everything to the 0 power is 1. So I could put, this is really 2 times 1, but we know that's just 2, so we're going to leave that as 2. So when we factor out a GCF, we're really dividing by that GCF and seeing what's left. I know that this is what's left, and I can't simplify it anymore because there's nothing else I can divide out of both terms, and I can't combine anything here because they're not like terms. This is the simplest it will get. So the factor form would be 4a times a plus 2. We could always go back and distribute to make sure that it works or it's right. So 4a times a, so if I'm remembering my exponent rules, if I'm multiplying like bases, I'm adding my exponents. So that would give me 4a squared. And then 4a times 2 would just give me 8a, which is what I had originally. So that works. So we're going to go through some examples where we're factoring out the GCF. For number 1, I'm looking at it, and one trick that you could use is when you're looking for the coefficients, look for the smallest number. That is usually going to be your GCF. I say usually because that's not always the case, so be careful. And we'll get to an example where it's not that way. So I'm going to say that 3 is definitely part of my GCF because I can divide both of these numbers by 3, and that is the highest number I can divide both of these numbers by. Now I'm looking at the variables. I see one of the terms has an x, but the other one does not. So that means I cannot take out an x because this 12, does not have an x. Can't take something out of nothing. So my GCF is just 3. I need to divide both of these terms by 3 and see what's left. 3x divided by 3 would just leave me with x. 12 divided by 3 would just leave me with 4. If I multiply that back out, 3 times x is 3x. 3 times 4 is 12. That works. Going to number 3, this is one of those cases where that usually doesn't work because the lowest number I have here is 8, but I cannot divide 36 by 8 and get a whole number. It'd be a decimal or a fraction. So what I'm going to do instead is list out the factors of 8 and the factors of 36 and find what is the highest factor that I can take out of both. So for these, you may want to make like a factor tree off to the side. If you know it off the top of your head, then that's great. So the factors of 8, remember that's 2 numbers that multiply to be 8. So 1 and 8, and 2 and 4. For 36, there's 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And when I look at these 2 factor trees and I compare them, there are 3 numbers that they share, 1, 2, and 4. And because it's the greatest common factor, I need to choose whichever number is the highest that they both share, so 4. Looking back at the variables, I see one term has an m, the other has an n. These are not similar, they're not the same, so I cannot take an m out of an n or vice versa. So there will be no variables in the GCF. And I'm going to divide both of these by 4 and see what's left. 8m divided by 4 is going to leave me with 2m. 36n divided by 4 is going to leave me with 9n. And if I were to multiply that back out, I would get 8m and 36n. Jumping down to number 9, the smallest number I see is 15. I can divide both of these by 15, so I can use that number. Now I have variables with both of these. I have a squared b and I have ab. So I can definitely take out a and b, but I need to know how many of each. Remember, we're looking for the smallest exponent of both. And remember, if it doesn't say, we can assume it's 1. So the lowest amount of a's we can take out of both is 1, because I can't take 2 out of 1 without getting a decimal or a fraction. And the lowest amount of b's, well, there's only 1. So I can take out 1a and 1b. And then we'll see what's left. So we're going to divide both terms by 15ab. And when we do that, 15 divided by 15 is 1. A squared over a is the same thing as a squared minus 1, or a to the second power minus 1, which leaves us with just a to the first, or just a. B to the first over b to the first is b to the 1 minus 1, or b to the 0. So that's just going to become 1. So the only thing left in the first term is a. In the second term, I have negative 30 divided by 15, less negative 2. I have 1a, or a to the first, over a to the first. That's just going to become 1, just like my b was before. My b over 1 over b to the first. We already did that. That's going to become 1. So this is really 2 times 1, but we know that's just 2. If we multiply that back out, 15ab times a is 15a squared b, and 15ab times negative 2 is negative 30ab. When you have multiple variables, in this case, they're in alphabetical order, which is why I didn't put 15ba instead. Okay. Looking at number 10, it is very similar. I see my lowest number is 16, but 16 is not a factor of 24. So I have to figure out what is the greatest common factor of 16 and 24. So I'm going to make another factor table really fast, or factor tree. 1 and 16, 2 and 8, 4 and 4. For 24, we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Looking at these, I see 8 is the biggest number, or biggest factor that I can divide both of these by. These both have b's and c's, but I have to look for the lowest amount, which is 1b and 1c. And then I'm going to divide each term by 8bc. 16 divided by 8 is 2. B over B is just going to be 1, so I don't need to put that. C squared over C, that's going to be similar to what I had for my A over here. So C, just C. For my second term, 24 over 8 is going to give me a positive 3. BC over BC, those are both going to cancel to become 1. So this is its factored form. 8BC times 2C plus 3. Let's keep going. For number 13, I'm looking at the two numbers. 5 is a prime number. Its only factors are 1 and 5. 13 is a prime number. Its only factors are 1 and 13. Well, negative 1 or negative 13. So I can't factor out any numbers, or my GCF will not have any numbers. And I see that I have two different variables, so I can't take out any variables either. So because I cannot take out anything, this one is in its factored form already. It's prime. I can take out a 1, sure. But if I take out a 1, it doesn't change. That was a weird 3, sorry. When I take out that 1, nothing changes. It's still the same. So this and this are the same thing. We don't need to factor out that 1 in this case. There will be times when we have to factor out a 1, but we will get to that later. Right? Moving on to number 15. Now I have 3 terms. Don't freak out. It's the same thing. We're doing the same exact thing. We're just looking for a GCF that works for all 3 terms now instead of just 2. Coefficient-wise, I see I have 2 2's and I have a 4. The lowest number I can take out of all of them, or I could divide out of all of them, is 2. I see I have x's and y's for every single term. I need to look for the lowest exponent. So for x, I see that's 1. For y, I see that's also 1. So I'm going to divide each of these terms by 2xy. And see what happens, or see what's left. For the first term, 2x squared over y, the 2's are going to cancel, the y's are going to cancel, x squared over x is going to leave me with just 1x. Remember your exponent rules. Negative 2xy squared over 2xy. The negative 2 over 2 is going to become negative 1. I'm just going to put the negative sign for right now. The x's are going to cancel, become 1. Y squared over y is just going to leave us with y. Because it was negative 1 and I'm multiplying it by y, I don't need the 1 in front. And then 4xy over 2xy, 4 over 2 is going to be positive 2. The xy's are going to cancel and just become 1. So my factored form would be 2xy times x minus y plus 2. Number 17. I'm looking at the coefficients. I see my lowest number is 6, but I can't divide 14 or negative 10 by 6 and get a whole number. So I need to, and you may realize this already, but I'm going to do a small factor tree for all 3. I'm just going to put 10, not negative 10. So for 6, the factors are 1 and 6, 2 and 3. For 14, we have 1 and 14, 2 and 7. For 10, we have 1 and 10, 2 and 5. So it looks like the GCF for these 3 is 2, or the number at least is 2. I see that each of these terms has a y variable, but I need to look for the lowest amount, which is 2. I can't take 4 out of 2 without getting a decimal or a fraction. So the lowest amount of y's I can take out of all of these is 2. And I'm going to divide each term by that. And see what's left. 6y to the 4th over 2y squared. 6 over 2 is 3. And then I really have to remember my exponent rules when I'm dividing like bases, I am subtracting. So this would become y squared. 14 over 2 is 7. Y to the 3rd over y squared is just going to leave me with y. Negative 10 over 2 is negative 5. Y squared over y squared is going to leave me with nothing, or 1. So I don't need to put that. I know that I'm finished because I cannot combine any of these inside. There's nothing else I can factor out. The inside is prime. We're going to do one more of these. Number 24. Now, 24 has 3 terms, but it also has 3 variables. Don't freak out, it's the same process. So looking at all 3, I see 3 is the lowest number, so that's going to be part of my GCF. I see all 3 of these terms have the variables a, b, and c. I need to look for the lowest amount, or the lowest exponent. For a, that's 1. For b, that's 2. And for c, that's 1. Be very careful that you're paying attention to that. So I'm going to divide all 3 of these terms by 3ab squared c. And see what's left. For the first term, 3 divided by 3 is just 1. A to the 3rd over a to the 1st is going to leave me with a squared. B squared over b squared, those are going to cancel and become 1. C over c is going to cancel and become 1. Negative 9 over 3 is negative 3. A squared over a is going to become a to the 1st. B to the 3rd over b to the 2nd is going to become b to the 1st. C squared over c to the 1st is going to become c to the 1st. For the last term, 15 over 3 is positive 5. A over a is going to cancel and become 1. B to the 4th over b squared is going to become b squared. C to the 3rd over c, or minus 1, is going to become c squared. So as I'm looking at this, I have an a squared by itself, I have an abc with a coefficient, and I have a b squared c squared. None of those can be combined. I can't take anything else out of this. I have an a squared and an a, but I don't have another a in the 3rd term. I have a b and a b squared, but I don't have a b in the 1st term. I have a c and a c squared, but I don't have a c in the 1st term, so there's nothing else I can take out. The inside is prime. I am going to multiply this back out just so you see that it works, because there were a lot of variables there. 3ab squared c times a squared would be a to the third b squared c minus 9a squared b to the third c squared plus 15a b to the fourth c to the third. Which is what we had originally. Right? I do want to mention this because I did not say this earlier. For each time I was dividing out the GCF, I would write it underneath and actually go through and divide each one. Once you get the hang of doing this process and dividing out the GCF, that may not be necessary, but until you get the hang of that, I would definitely recommend doing